about the European elements on the ISS and like to give you a few examples and aspects how they can be utilized for the preparation of a human exploration program. And just to mention, I'm not a scientist if I talk about scientific experiments, so please excuse me. I'm having so many much more qualified persons, maybe even you can answer some of the aspects better than I can, but we'll see. What are the elements? The elements here from we are contributing from Astrium. It's ATV, our logistics carrier. After shuttle retirement will be the most complex logistic carrier to bring resupply to the station, but also to serve to reverse the station. And launched on an Ariane rocket, approaching with an automated rendezvous and docking capability to the station. I think it has a lot of capabilities not only to serve now in the context of supplying the station with resupplies, but also in any exploration schemes to come. And it's not only an unmanned cargo vessel as such, it is manned during the time you connected to the ISS, so it's frequently used by the crew. It's silent, it doesn't have a life support system of its own, so it's really a retreat, and I think it really shows, if you talk about prolonged stays, you need these kinds of areas on a station where it's not having all these blowers and loudness for the crew. The other element, Columbus, the European Research Module. Astrium is the architect and operator of this facility. And as it says down there, we feel we are the enablers of science application, and hopefully also an exploration program. We are not running it. But it's in orbit now since 2008, February. It's running fine. And a lot of research has been done externally on external platforms of Columbus, as well as internally in the station. To the left, you can see the microgravity science glove box. To the right, there are, it's not really so easy to notice, but on the right there are two facilities I think very important for any exploration-related research, the BioLab and the EMCS. Both have centrifuges where you can perform experiments from 0.1 G up to 2 G and really have a reference. You can run experiments at 1/3 moon or 1/3 Mars gravity or moon gravity. And it provides a lot of volume for exercise and life sciences and experimentation in life sciences. The life support system also, the less you hear about it, the better it is probably. It's running fine. And then what we're also doing, we provide research equipment. And I think ISS really offers unique possibilities to understand our planet. We're presently just now running an experiment, GeoFlow, to look even in the inner core of our planet, to simulate the magma streams inside of our planet, something you wouldn't be able to do on Earth. But certainly if we talk today, we also can use ISS much more for exploration, to look into other planets, but still with a goal to understand what our planet is about. ISS, as we heard already, is a perfect model for a closed system, a closed ecosystem. We are still working on new regenerative physiochemical and also biological system to enhance the system, but also to reduce the need for resupply. And in the end, whatever we do for exploration is a wonderful model which will also serve back on Earth later on to maybe solve our problems in cities and so on. And facilities like EMCS, as I mentioned, is a gravitational facility with a centrifuge, so we can perform experiments on Mars, moon gravity, and see how do biological life support components, but also food crops develop over time. Do they stay stable? Can we depend on such system? Can we put them into the planning? We do materials research. We do also pharmaceutical research. We heard already today about microbials changes in such an environment, so it's very crucial to continue this type of experiments. And then there's a lot of research done also in osteoporosis, immune deficiency, and reduction of muscle and fitness, and to look into countermeasures for this. always related also for us to look into health problems on Earth in the elderly, which is very close to the phenomena happening in space. But is this really all enough already what we do there now with basic research to prepare for a mission to Mars? A lone US astronaut has a lot to encounter if he's on Mars. Maybe it's a little overdone, the aliens hopefully will not be there, but also other nice pictures you can find, an astronaut climbing a wall, even just walking on the surface, as we heard, with equipment quite heavy, will probably be very difficult. And we heard also today already about the Mars 500 experiment, where they tried as much as possible to simulate such a mission, but certainly not with microgravity conditions. So if one looks at these pictures of a Soyuz landing, luckily there is help coming quickly, and the helicopters are coming, and the crew is helping the astronauts, the cosmonauts, when they leave the capsules. And even after a certain period, when they come back, you can see they walk down from the airplane, they are still helped, the balance control is still not really working well, and people are quite concerned something could happen. So what really is happening, I think conditional problems is one thing for them if they arrive. It doesn't really matter so much, the cardiovascular and muscular skeletal system during the time they stay in orbit can adapt. There's no effect for a normal ISS crew, but when they come back to Earth, the readaptation takes a while. If you talk about a short Mars scenario as we did today, we probably cannot afford another 14 days before they're able to go on an exploration on the surface. There's a lot of conditioning, exercise equipment on board the ISS, so I think the conditional things alone maybe to a certain degree can be overcome. What's the problem is the coordination situation, the sensors, the vestibular organ, the optical information give you different information, so you have the spice nausea in the beginning, but after a couple of days, most of the time, it's also quite okay. But when they come back, the same effects can occur, and certainly for an arrival on Mars again, this could be a problem. And there, up to now, there is not really a good countermeasure existing, to my knowledge. So the sensory motor system is fooled. We don't have the good signals from the vestibular organ, and we don't get the response from our muscular system. And on ground, in elderly, after traumatic injuries and so on, you have similar situations that your balance might be not working, your balance control. So what you can do is you really go on these kind of moving platforms, and you can train your reflex system to overcome the balance problem. And you develop a countermeasure, really. This does not work really in microgravity. We don't have the vestibular system, but also not the loading, since we are floating free. So what we developed there together with the university in Freiburg, Professor Goldhofer, a system how to load a subject to such a level moving platform, but you just have the loading downwards, and you still can fall freely to the side. So you can really perform this kind of testing, how to find your equilibrium even in a microgravity environment. And we are just now in June preparing for a parabola flight verification. We try to use parabolas which are simulating Moon, Mars, gravity and zero gravity, and compare indeed the behavior of a zero gravity together with a loading system, and which is then tailored to Mars gravity, to a gravity campaign with Mars values. And well, we found this works perfectly well using gaming consoles like the Nintendo Wii balance board, and we have been running programs that students now hopefully could be combining training with fun on board ISS and maintain the equilibrium sense by just performing a couple of games per day. Certainly this is not giving you all. It might be better to combine these kind of countermeasures, and the ultimate tool in the end would be a centrifuge on board ISS, where you have your vestibular system not correctly loaded to the Coriolis forces, but nevertheless you have the loading of your bones, of your muscles, and you have your most realistic artificial gravity. There are two concepts presently. We're running a study for ESA to accommodate a centrifuge either in MPLM or an ATV module, diameter between 3.1 or 3.9 meters. So hopefully giving you the capability to run exercise on this centrifuge. And then we run some kind of science workshop with about 20 experts doing ground-based research. So there seems to be an understanding that with protocols of about doing 3 times a week a 1-hour protocol, or 16 times a day for 5 minutes a protocol, you might be able to maintain your capabilities, your sensory motor capabilities, and also your cardiovascular, skeletal, muscular and vestibular training. And that's how such a system would look like, modular system. To build it up, you have your counterbalance system, so you don't disturb the microgravity environment on ISS. Okay, I think this. Okay, and then we always try to go back and to apply these results also on ground in rehabilitation, geriatrics, where balance is one of the major problems in the elderly society.